Hi, in this project, we will be building a machine learning model that is able to recommend restaurants to our users. So let's see how we are going to implement that. What does this project entails? Now a recommender system or a recommendation system has an ability to predict whether a particular user would prefer an item or not based on the user's profile. Recommender systems are beneficial to both service providers and users. In this project, we are building a recommendation system or a recommendation model that will recommend us restaurants in a particular destination, taking in your latitude and longitude geographical location. Details for the project. We will be taking in our dataset and train our model according to reviews it has and the location it has using k-means clustering. We will also see how to portray geographical data onto our collab file using Plotly libraries and GeoPandas libraries. These two are the main libraries and some more dependencies. Lastly, we will be building a basic function that will take geographical data as input, that is our longitude and latitude values, and recommend restaurants to the user. For people who are not much experienced in machine learning or maybe have not understood or not have used Plotly library or maybe GeoPandas library, I would recommend you to see or to at least go at the links that I would be providing later on for those libraries to understand what all features those libraries provide, why I have been using them, and what more you can use those features or those libraries for. So the next is machine learning model. So we start off with building a machine learning model. That is our like main point, and we are using k-means clustering model and train that using the Yelp dataset that we have. So I've just given this as a pointer that for this project you will have to understand all the libraries used before you start implementing the code. Why I'm emphasizing on this is because these libraries are not much used by people who are just doing simple EDA or just building a simple model on a very, I would say, non-complex data set. So this is like a brief about the types of recommendation systems that exist. So there are mainly two types, and then there's the mixture of both the types. The first type is content-based filtering systems. So it makes recommendations based on user preferences for product features. So this type of filtering is based or is dependent upon users and their behavior. Now next is collaborative filtering. So it mimics the user to user recommendations. Now here this filtering is actually dependent upon the product and who or how many are recommending that product. It is not dependent upon the user but the product itself. So I will be discussing more about these systems in later videos. And yeah, lastly, let's now move on to the code part of it. And there's a quite bit of theory where I'm explaining about the libraries or maybe about the Plotly, some of the functions in Plotly that are similar to Matplotlib, but can take more parameters or can output even more detailed graphs for the data set. So yeah, let's move on. So in the first type, we make recommendations based on user preferences for product features that I've told. Now it can recommend a new item but needs more data of user preference in order to incorporate best matches. Now these type of recommendation systems take in a lot of data, meaning a huge, very big data, and then it is able to precisely tell you what kind of recommendations or would give you a recommendation that might suit your taste. In collaborative filtering, that is the second type, it mimics the user recommendations. Okay. This predicts the user preferences as a linear weighted combination of user preferences. So if you know the math behind linear regression, you know it has some of the features and some weights for it. And it builds a linear function for it. It can go into multinomial form also. But in simple regression, we have a linear function which has features as values for x and its weights, and lastly bias. So in a similar fashion, collaborative filtering also builds a linear weighted combination that is using the user preferences that it has already got from the dataset. One thing to note is that content based filtering does not require other users' data during recommendations. So, just like I told you about that content based filtering actually depends on user, but it doesn't mean that it actually depends on users. It only depends on one user for which it is providing you recommendations. Now, you can see that a lot of packages are there that I'm downloading, and you have to also download all of these and then install them because these don't come as a default with the Google Collaboratory. Okay, so don't be, get scared from whatever I've written here. This is basically an Ubuntu command telling that you have to install the GDAL library. Okay, so first it downloads it and then it installs it from the bin, and it's telling that yeah, you have to use Python GDAL. So this is like for Python, this is for Python 3. So whichever is present, you can just download that. Next thing is that I've already given you a link. Okay, so you must, I think you must go at least at the link and understand why I'm going to use GDAL library. Okay, so this is a library of tools. Just like I told you that half of these libraries are just going to be dependencies for GeoPandas or Plotly, or they might be having some features that are or some functions that are going to be used by Plotly and GeoPandas. Yeah. So GDAL is a library of tools used for manipulating geospatial data, basically geographical data. Okay, and it also comes with a variety of useful commands and utilities for data translation and processing. Now, even if this is not something that you're able to understand, just go through the link. It gives you a basic description of what GDAL does, what it has, and some code implementations of basic functions. So now moving forward, we are now installing R-Tree. So next, that is R-Tree. This is a Python wrapper of Live Spatial Index. This is again another package that provides a number of advanced spatial indexing features for the common Python user. Again, this might not be something that you're able to understand. No problem in it. Just remember this that R-Tree is something that is going to be used by GeoPandas. Okay, since all of the languages, say Java, be it Python, or maybe even C++, they have used abstraction. So what you know is the output to a function. It might be like you don't know how that function internally works. That is fine. But just remember the relation between R-Tree and GeoPandas or maybe some other library with another library and why I have downloaded them or installed them. Okay. So just like I told you about, R-Tree has some of the features like nearest neighbor search, clustering indexes, etc. So you can even understand from the name itself, nearest neighbor search. Now in K-means we know we are building clusters and we are searching through them. So again, you might understand that yeah, R-Tree might be or might being used somewhere, right? Though it is not used in K-means. Let me just tell you that. And the next library is GeoPandas. Yeah, this is a very, very main library. So from the name itself gives a hint of what it might be. So GeoPandas is a project to add support for geographic data to pandas objects. Okay. So I've already again
provided you with the link for GeoPandas. So you can see from the link provided, if you visit the actual README for GeoPandas, you will understand where we are going to use this library. And rather than just skipping, I would actually, go to this link and show you about GeoPandas. So you can see that the latest version was released on March 1, 2021. It has a lot of collaborators and contributors. And if you scroll down, you can see the introduction for GeoPandas. And you can even go to the docs and see what all functions it has, how to actually use and implement GeoPandas. And you can see that R-tree is another dependency that it requires, and that light spatial index that I was talking about was a C library, for which R-tree was the Python wrapper. Now what I wanted to show you actually was not all of that, but this. See, this is a borough boundary of New York City. Okay, it is in the format of a Fiona file and read as a zip file, and you can see this map type structure. So you can see that here as an example, it has shown that they are reading the file, and that file is present inside this variable, and if you print this variable, it gives you a map for the boundaries of the boroughs in the New York City. So you can understand from here that yeah, GeoPandas is what we're going to use for mapping or for implementations of maps. Now, why I'm going to use this in this project is shown later on, and it is a pretty cool thing. We are going to build an interactive map, okay, that is present on your Google laboratory file or maybe a Jupyter file. Okay, so moving forward, now the next library is Descartes. So if you don't know about Descartes, then he was a mathematician. Okay, you can even search that. The first time I searched about Descartes, what it showed me was the name of the person, not the Python library. And now installing Descartes, which is actually a dependency required for using GeoPandas. See, just like I told you, half of them are actually dependencies for GeoPandas or Plotly. It basically helps in forming and plotting Cartesian planes. Okay, so you in the last example saw that there was a map defined on a Cartesian plane. Now that was just a static image. To make it more interactive is what Descartes is helping in. So this is an important library that we are going to use, and I'm talking about Folium. So Folium is a Python library used for visualizing geospatial data. It is easy to use and it is a wrapper for leaflet.js. Now again, Folium is a Python wrapper of a package that is built in JavaScript. And we can also pass rich vectors, rasters, or even HTML visualizations as markers on the map. Again, this might be a little hard to understand what I'm talking about. But what you have to understand is that, say, I've already built an interactive map and I have specified some points on the map. Okay, it might be location of an airport, might be location of a restaurant, might be location of a mall. So if I hover on it, then it gives me extra information. So that hovering interactive thing is what I'm talking about by HTML visualizations on markers. Okay, yeah, as markers. So lastly is Plotly, and when installing Plotly, it is a better version of Matplotlib used for data visualization. We can make interactive and line visualizations over the normal static visualizations of Matplotlib. So just like I told you about, Matplotlib, whenever we are using, gives you a static image. Okay, image is actually static only. But so basically it gives you just an image, and you can't maybe change the input, or maybe you can't hover on it and understand more about the data, which Plotly is able to manage, and you will see later on. So this is a very large part, and I've totally explained the major libraries that we are going to use, and you have to install all of these. And this gives you a lot of code and unpacking of code and installing of these code. So ignore that unless it is giving you an error. Even if it's a warning, you can go forward with it. But if it is an error, you might have to search the solution for that. So I've just imported all of these libraries. Here you can see I've imported k-means and a metric that is select score. Again, why we are going to use that or how, I'm going to tell you. The next part is we are actually getting the data. So I told you that this is a Yelp data set, and we are getting that data set from a Dropbox. And then I'm just unzipping it so that I can access all of the files or the CSV files of the data set. So this is I would say, a subpart for building the machine learning model. And in the next part, we will start looking at the data set and the exploratory data analysis of what we are going to do. Now, before just going forward, I would again ask you to understand what all of these libraries that I've just downloaded and talked about. Just go through the links, maybe search even more about them, so that again later on when I'm giving you the details about the functions that I've used, it might not happen that once I've explained, you might understand it in one go. But if you have learned about the libraries, it might be easy to understand. Okay. So moving on to the second part, I would say, where we're going to handle the data, do exploratory data analysis on it, and maybe feature engineering also. So once you have downloaded and unzipped the data, you can access the data using the read.json function. Okay. And here you can see that using the head function, I'm calling the first 5 data points of my data set, and it has business ID, name, address, city, state, postal code, latitude, longitude, stars, and many more columns. Okay, but what some of the columns are, I would say, what columns are actually useful to us is or I would say for this project, I have taken review count, stars, the geographical location, city as the important columns that I'm going to use, on the basis of which I'm going to do the recommendation. So you can see that attributes, categories, and Rs. These 3 columns actually have dictionaries as values also. There is none value or null value, but there's dictionary also. It has string values having commas telling you all the categories. Okay. Then it has, again, Rs has none values, dictionary values telling you that on Monday it's open from 9 to 12, Tuesday it's open till 9 to 12, then Wednesday, and so on for each of these restaurants. Now, again, you can see that not all of them are restaurants. See, the first data point has the name Arizona Baltimore Golf Club. Yeah, Golf Club. Again, this is not a restaurant. It might have a restaurant, but again, we are just recommending people for a restaurant. Like if a user asks me to recommend them some restaurant, I won't say that, yeah, I'm going to recommend you a golf course that has a restaurant, and maybe it won't be even free for people who are not playing golf there. So that is kind of useless. So first thing what we are going to do is filter out only those, or I would say filter out all of those shops, restaurants, mall, etc. that don't have any restaurants in it, okay, or are not even a restaurant itself. So another thing to specify is that this data is for Northern American states, okay, and you can see using the shape, it has 192,000 data points with 14 columns, and again you can see here that the first thing I'm doing is checking out if each, I would say, each shop, not a very good description to be given to uh, golf club, but let's say this variable, yeah, doesn't have restaurant in it, in its categories column. So you can see that this is a string. So if I'm looking at, okay, I'm again typecasting it and looking for restaurants in it. If it has restaurants just like it has here, then I'm going to include this in my filtered out in, or I would say into the restaurant data set. Since it doesn't have restaurants in it categories, then I'm going to remove this. So for each and every data point, I'm going to search, and only those who have restaurant added as its category will be taken. So you can see that I have inputted a new column that is restaurants and put it as true for all those that have restaurants as its category. You can see true, 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 true for all of these because all of them had restaurants. You can see restaurant here, restaurant here, restaurant here, restaurant here, restaurant here. Yeah. So now we have only those. Basically, we only have restaurants now. No golf club, no malls, no shopping complexes, etc. You can see that it has the dimensions have reduced quite much, meaning a lot of data has been filtered out, and we have only 59,000 data points with us. Now using matplotlib, and we are going to look for the counts for each and every star or rating. Okay, the rating is ranged from 5 to 1, and you can see that most of the ratings are, yeah, 3.5 and 4. So ratings of 4 and 3.5 are the most for all the restaurants that we have taken into consideration. Ratings of 5 have been given to very less, and rating of 1 is given again to very, very less number of restaurants. Okay, now I did specify that Plotly is better, or I would say more robust version of Matplotlib, but that doesn't mean that I'm going to, just shut out Matplotlib or push it out. For static visualizations, of course, I'm going to use Matplotlib because Plotly, Plotly might be more interactive, might be more appealing to the eyes, but it also can takes a lot of processing power. Okay, so next you can see that I'm using the sort values function on my data frame. So here we can see that we are using sort value function with which we are sorting the data frame on the basis of the parameters that are sent in the by parameter. You can see the by parameter here, and the, I would say, the bases are on review count and stars. First it checks for review count, then it checks for stars, and then it takes the weighted average for both and then gives the output of it. So it takes two columns that are review counts and the stars to sort the data frame, and by setting the ascending is equal to false, we have sorted the data frame in descending order. So here the next parameter is ascending is equal to false, and by which what I'm asking is to sort the data frame in descending order, meaning the highest rating and the highest review count is to be shown first, then the second, then the third least, fourth least, and so on. Now we can even set where to show the null values also, meaning if this data frame had any null values in it, so we can present the null values using the no position parameter. So if I give an input of no position is equal to last or is equal to first, then it would mean that all the null values for review counts and stars would be shown either at the first or at the last. I'm not giving this because there is no null value. And now here I'm just only taking the first 20 values and inputting that into the top restaurants variable. So all the restaurants that I filtered out, I'm taking the top 20 restaurants on the basis of review counts and stars, and now setting that up into the top restaurants parameter. Now using that top restaurants, I'm building an graph to show, here you can see the ratings for each of them, and going downwards is the and decrease of review counts, meaning Mon Abi Gabi is, if this is what it is spelled and pronounced, then here you can see this having the most review counts. Okay, so that is placed first, and for that, what is the rating for it? You can see that is 4. Here it is showing it is going even more than 4, maybe it would be 4.5 or 5, whatever. But this is what it is given. Now, this is the part where I'm going to use Plotly. Okay, but from here, before moving forward, let's understand how to use Mapbox map with Plotly. So to make this Mapbox map with Plotly, you will have to make a Mapbox account. Now again, before moving forward, I would ask you to set up your own Mapbox account, and I'm going to show you how to do that, which would be again in the next section. So yeah, now let's start with building or creating an account at Mapbox. Okay, so to actually make these kind of maps, yeah, so you can see here that I've created a map for United States, and now I can even zoom in it, zoom back, hover on it, and it gives me the review, the latitude, longitude, the stars. Again here, it has a lot of it has a lot of restaurants present here, and you can see by hovering each and every of the extra information present for each point is being shown here. And this color change is actually defined for stars, that a 2 or 2.5 will have this many, a 4 or 4.5 will have this many, and yeah. So now let's move forward. So just search Mapbox and click on sign in account. So yeah, so it's already signed in for me. What you can do is go and just sign out. Now yeah, this page is what is going to be shown once you click on that link from the Google search, and here you can click on sign up on useless sign up on Mapbox, and just input your details and credentials and click on I agree and get started. So since I already have Mapbox account, I'm going to sign in. So once I sign in, you can see the dashboard for Mapbox, and here you can see that I already have a default public token, and it asks me to create a token also. You can create a token or you can use the default public token. So just copy this and paste this here. So now you will have your own token present, and for that you can just use the token and build maps on your own profile or maybe on your own Jupyter or Colab file. But one thing to understand here is that Mapbox gives you only 50,000. It might look a very big number, but it is not. So it will only give you 50,000 free loads, meaning that if I reload this, it would increase the load by 1. And now I've used 2 loads out of 50,000 loads for the maps. So once this is over or this is finished, you might have to pay so that you can use the Mapbox account and create maps on your files. So again, 50,000 is much if you're just going to implement this project. But unless if you're going to move forward in that direction and use or maybe handle geographical or geospatial data, then it might be good for you to pay as you go. So for me, since I just have to build this project and show you the power of Plotly, I've just used the free version. So you can copy your own or maybe use my also, my default token. But once 50,000 is over, that means this key won't work and these maps won't load. So yeah, now let me just give you a brief about the set mapbox access tokens function and scatter mapbox function. Okay, so it is pretty clear that set mapbox access token is just going to take the default token or maybe any token that you have provided and works as an authenticator that yeah, you can use mapbox library and its features. Okay, but to actually build maps you have to use scatter mapbox, sorry, mapbox. It sounds like a and twister to me. So just like I told you, if you don't have one yet, you can just go on the Mapbox and create the account, use the default token, or maybe create your own token also and use that. Now, using the function scatter mapbox, we are going to build the map. Here we input our data that has already the latitude and longitude. Okay, we then just define them with latitude and longitude parameter. So you can see that we have input the data, that is DF restaurants, having all the restaurants. Then I am telling that inside this the latitude column is to be filled in the lat parameter and the longitude column is to be filled on the in the longitude LON parameter. And then the next parameter is color, that is for stars, defining that here you can see that the value or the range is 5 to 0, and for each range it has defined some color and that is depicted here. You can see that if I zoom in, I got zoom in, yeah, if I zoom in, you can see that there's a down, yeah, here down, you can see there's a dark orange, a light orange, a yellowish. So it is defining the range of maybe 4.5 to 4 or maybe 5. Yeah. So this is what colors parameter is taking and doing. Now size is review counts. Now that means the marker. Here you can see this is a very big circle. This is a small circle and some fuzzy circles. This is small. You can see a lot small points. So this size is actually what is defined by review count. Again, this is zoom, how much you can zoom in. This is width and height. The width and height for this map, interactive map. Yeah. So next what I'm doing is taking the state NV, North Vegas, and only taking the North Vegas side and again building another map to see the, yeah, here you can see a lot of restaurants are present with different ratings, and you can see if I hover here, if I hover on one, you can see review count is 6, latitude, the longitude, and the star for it. Here again you can see, again you can see. So this is what I'm talking about. Now for this situation of this kind of just building and defining restaurants, you can do that. But even for different kinds of data, like say police killing in some area, you can take any state, you can take the data for the police killings, the state and the longitude and latitude place, and it would again give you a map with different places where police killing took place. And if you specify the hover data, this like the review count and such, it will tell you how many good killings have taken place at that point or maybe some other attribute that you have defined. Okay, finally we have reached the model where we are going to build and train the model. So we're going to use k-means clustering. And now the first thing is to determine the number of clusters to be formed. Again, either we can just directly put in some value of cluster that we want, or we can, through two methods that are elbow method and select method, we can find the optimum value of k, that is number of clusters to be formed. Now, by finding optimum value of k, we can say that the prediction or the recommendation given by this k-means model would be highly enriched and precise. So for that reason, we are optimizing and finding the best value of k. Now, if you already know about the elbow method and the select method, then it's good. If not, I'm just now going to explain what both of these methods are and how they're optimizing or finding the best value of k. So the elbow method is one of the most popular methods to determine this optimal value of k. Here you can see that I've taken distortions list and sending in some values, that is the inertia value. And next you can see that I am now building a graph for distortions and the values of k. You can see that for values of 0, 5, 10 that are defined for k, a graph is made that is decreasing in some order, and then from, I would say from here, somewhat here, you can see that the decrease is now linearly. And in elbow method, we just have to find the point where the decrease in the value for distortion starts in a linearly fashion. Okay, now you might be thinking what distortions or inertia is. So distortion, it is actually the calculated average of the squared distance from the cluster centers of the respective clusters. Meaning, let's say there are four clusters. So I would say cluster 1 has center 1, and similarly cluster 2, 3, 4 have center 2, 3, 4. So I'm taking the distance between 1 and 2, then 1 and 3, then 1 and 4. Now I take the average of all of these distances. That is one distortion. Similarly, for 2 point, I would say 2 distance from 2 to 1, then 2 to 3, then 2 to 4, then take average of it. Similarly, for each and every number of k and each and every distortion for each number of k. Now this is a little bit confusing, but what I want to say is basically, say there's 1, 2, 3 clusters. Only 3 clusters are to be found. Then in distortion of 1, I would say distance of 1 to 2 plus distance of 2 to 3, distance of 1 to 3, okay, divided by 2. So this is distortion for 1. If I want to take distortion for 2, then I would say distance from 2 to 1, then distance from 2 to 3, and divide by 2. So now if I now increase the value for k, so now I'm assuming that k is equal to 4. So 4 clusters are to be formed. Then distortion of 3 will become, distortion of 2 will become this. So like this is how it is actually calculating the distortion. Okay. And now inertia. So it is the sum of the square distance of samples to their closest cluster center. What this is meaning to say is that, say there are 3 data points. Yeah, inside this, let's say there are 3 data points here. Okay, so the cluster would be between here, some point here. So we are taking the distance from each and every data point, okay, from the cluster, and say the distance from data point 1 to center is d1. Similarly, for data point 2 and 3 is d2 and d3. So we're taking the sum of the squared distance. So that is d1 square plus d2 square plus d3 square. This is what inertia is. Okay. Now what we are doing is calculating inertia for each and every cluster and taking the sum and then inputting that into the distortions list. And for the range of building K from 1 to 24. Now using that list of distortion, I am building the elbow graph. So here what you have to see is the minimum or actually the maximum point from which you can see a linear decrease in the value of distortion. You can see for the first value it drops down to more than 20 if I move second point from first point to the second point. Yeah. So let's say this is the value for first point, this is the value for second point. So from moving first to second point, you can see a very large decrease. Then the decrease has diminished and again diminished till to the point where now there is no diminishing decrease. The decrease is constant. You can see from here. So we are taking that point. And even if you go and look forward, you could see that at the value k is equal to 5 or around 5 is the most optimum point for our k means to take 5 clusters. So we have taken that our clusters number of clusters to be found is 5. Next we are going to talk about is the second silhouette method. So the second method is silhouette method, where this method computes the silhouette coefficients of each point that measures how much a point is similar to its own cluster compared to other clusters. So what we do is we compute the silhouette coefficients for each and every point, and the average of it is called the silhouette score. So the silhouette value is measured of how similar an object is to its own cluster compared to other clusters. The value ranges between 1 to -1, both inclusive, okay, and where a high value indicates the object is well matched, that is, if a value ranges or is closer to 1, that means that that object is pretty much similar to that cluster. And if the value ranges in or is closer to -1, then that means that the object is not as similar to the cluster it is belonging. So for computing that, what we do is first we compute the average distance of the points with all other points in the same cluster. Meaning, let's say there are three clusters, cluster 1, 2, and 3. Each cluster has 3 points. Okay, so what we do is for the first cluster, taking the first point from that cluster, we compute the distance to the two other points that belong to the same cluster. We take the average of that. Next, we take the average distance of that point with all the points in the closest cluster to the cluster. Meaning, let's say now that I've taken the averages from the cluster 1, I see that the cluster 2 is closest to cluster 1. So I take the value 0.1, okay, from cluster 1, and I take the distance of that 0.1 from all the other points of cluster 2. Then I take the average value of that. Okay. Lastly, what do I do is for calculating silhouette coefficient, I take the first point, okay, that is where we calculated the average of 0.1 from the other clusters. Let's say that is B. So that average is B. And the averages of zero point 0.1 from the points in the same cluster, that is average, or I would say that is A. So what to calculate silhouette's coefficient, what I would do is I would write B minus A upon maximum of B and A. Okay, so this is what is happening under the hood, and that is actually being done here and then being done here. So silhouette score is actually what is being this silhouette score is what actually is calculating all that Sillits coefficients and then taking the averages of that. So what I just now explained in terms of mathematics is what is happening inside this select score function, taking the value coordinates, okay, and the labels. That is the clusters, meaning the label can be cluster 1, cluster 2, or cluster 3. So if I just print sil, it now has all the cluster, or I would say the select coefficients for each and every value of k. If k is equal to 1, that means only one cluster was present. If k is equal to 2, that means two cluster was present, and select score, or that is select score, is now calculated for both the clusters. So you can see it ranges from number of clusters equal to 1 to number of clusters equal to 24, and you can see the values for each and every. Now you can see that these values, see, this value is greater than this value. Meaning, if I say this is the value of k here being 14 and this is 15, that means that a cluster having 14 cluster is better than having 15 cluster. So we find the maximum value from here and then input the number of cluster. So from both of these methods, we find that 5 is the best value for the number of clusters to be formed, and that is what we use. Now, next what we do is, but what we understand from here is that no, maybe 5 is not the best value, since select score is 0.38 and we saw or 0.44, 0.5. So I have taken the lesser value is because it actually takes a lot of time to train the model if I build 14, 15 clusters. So if you have time, then you can actually input the best number of cluster. You can see that the value here is 0.453, this 0.455. I think this is the max value, or 23. So meaning 23 clusters can be formed. Now you can input that and then train the model and use it. But again, for simplicity, I've just inputted 5, which you can even see in the elbow method is the point where major part is not, meaning where the decreasing or the rate of decreasing has diminished at a very fast rate, meaning that here it was, the value was diminishing in very fast rate, but here you can see that the rate of diminishing or decreasing has also decreased. So I've taken 5 here. If you can move forward, I might have taken 7 or 8 here. So for simplicity, I took 5. But again, using both of those optimizing methods, you can actually input the best number of cluster here also, or the optimized value for the number of cluster here. Next, what I'm doing is using the predict function and giving the input longitude and latitude. So these are what my points, I would say, the on the Cartesian plane, longitude and latitude are the points that are being built and upon which predictions are to be done, and for the which cluster that location would belong. Since each and every location is mapping to a restaurant, that means here the prediction is done for which restaurant belongs to which cluster. So now you can see that a new column I have created named cluster, which is telling you the number of cluster or the name of the cluster which this Dairy Queen restaurant belongs to. Yeah. Now what I'm doing is again building a map which is now based on not rating but clusters. Okay, though it is giving you a point of 3.5 and 2.5, there's no 3.5 and 2.5 present here. It's either 4, either 3, either 2, or either 1, or either 0. So that's why you won't be seeing any orange color. You would directly be seeing either yellow or either dark orange or magenta pinkish color and purple color and like blue color here, and that is what you can even see here in the map. So another thing is that here I've already defined hover data. Before I didn't define hover data, it took the values from lat, long, review, and sorry, size and color. But here I have also defined hover data that is telling me that even showcase the name, and both of these are already superimposed, so nothing more to present. But you can now see that even the name is present, that is Cinnaholic, or maybe Boogie's Bars and Grills. So that is what I was talking about, that we can even visualize more, even input the HTML part and give more details about the points that we have marked on this map. So this is the last part where we are working upon the location based recommendation system. So I've even stuffed the data and only using the Las Vegas part of the topography. Okay, and only since I've already made a predictive algorithm, or actually trained the k-means clustering. Now what I'm doing is taking a subpart of that data that is only having Las Vegas restaurants and doing the predictions for only Las Vegas. Sorry. Now you can see I have created a simple function that is taking the df, that is my data or data frame, and the longitude and latitude. So if I'm just taking the top restaurants for Las Vegas and giving an longitude and latitude for, let's say, wherever you are present right now, it would give you the latitude and longitude for all the restaurants that are close to you, or that are close to you and have a high rating or review count. So you can see that taking the longitude and latitude as parameter, it is predicting, and we're just reshaping to just get the best cluster, to just get the cluster out of it. Okay, and from there you can see that it is printing that for this set of parameter or geographical location, the restaurant belongs to class 2. Okay, and the top 5 restaurants for this cluster are these, having these latitude and longitudes. Meaning, if you're liking restaurants from cluster 2, it is going to provide you with the top 5 restaurants of that cluster 2 with the geographical data about where it is present. That is giving the latitude and longitude. Now, you can even see that in recommend restaurant, again using that function, if I'm giving this as the parameter. So I would say that I'm giving this data, or the place where I want to search about the best restaurants present around it. So you can see that it is giving me that this place is defined by cluster 0, and the top 5 restaurants present anywhere close to these coordinates are these. Again, for this I have shown you. So it takes cluster 4 here, and I've just made a testing data to again test if it is working, and if it is working, then to create a map for it. Now you can see that here one cluster is present and here another cluster is present. Actually, what it is telling me is that I gave the input of this location, and the closest cluster is present here. Okay, and the top 5 restaurants are all of these that are named here. Okay, even if you go forward and look at the second map, so you can see that if I am present here, okay, that is giving the coordinate for this location, it again gives me that this cluster is what you belong to, and the top 5 restaurants belonging to these cluster are present here, here, and here. So you can just move and go to this restaurant. Again, for the last part, you can see that if you are present here, then again, I think this is the same one. So with this, we can say that we have finished the location based, I would say, recommendation system. Okay, but one thing to notice, or I would say one thing to keep in mind, is that we have just used the Las Vegas, or I would say the sub part of the actual data set, and now we are just predicting which restaurant might be the preference. Look, if the user is giving me this location, okay, what you can do is, maybe rather than just taking Las Vegas, you can use the whole of the data set. Or what you can do is, rather than just using the Yelp data set that I am using for this, you can even take the data set that is generated in your country and can easily use that data set with these methodology and code implementation, and even you can build a recommendation system based on location for restaurants in your own country. So with this, I'm going to complete this project. And if you have a lot of knowledge about web applications, how to build them, and embedding maps and all, then you can even push forward this project to build a web application of location based recommendation system, even showing maps. Okay, but for this project, the scope ends here. Hope you liked it.